Everybody got the water? Well, I hope we'll find out that I'm not Dr. Doom. I hope to be Dr. Hope today and talk about Whidbey and our water and what we know. So good morning to you. Lovely to see you out today. I have this photograph, this video. You'll see this is a spring on Green Bank Farm in that property. Many of you may know this spring. We're going to use it to listen today. And I'd like to open with a prayer and then an inspiration. The inspiration comes from a person called She Keeps the Feathers of the Mohawk Nation. So, great Creator, thank you for this day. Thank you for this opportunity to get closer to the sacred waters of our earth. We ask you to open the ears of our hearts to listen as water speaks through these wise words. Water speaks. I am the blood of Mother Earth. I am your blood. I carry your ancestors' memories and teachings through your every cell. You are made from them. You are still part of them. You carry their experiences, knowledge, and love. In the womb, you breathe me before you breathe air. I am your mind, clear when calm, cloudy when turbulent. I am emotion that disguise myself as tears. I am rain, lakes, streams, oceans, snow, ice, and fog. I am your tea, your soup, and your reflection. I am so powerful I can shape rocks. And the rocks are your ancestors. I talk to them, and in return they give minerals. And the minerals are your stories. When you drink me, you receive knowledge and health. When you are surrounded by me, I hold you. When you're in my way, I go around you. I am medicine. You are medicine. I am medicine. You are medicine. Oh, talk to us. So, my topic today is water on Whidbey Sustainable. Now, I'm going to take a high-level view here and hope to enthuse you into the thinking about what we can do with our water here. And I'm Perry Lovelace, but really, you know, what we want to ask is about 4 essential questions. The first question is, how much water is there? Is there 10 trillion gallons of water that we're sitting on? Or is there 3 trillion gallons? Or 100 billion gallons? Or, gee, I sound like a cemetery. So we want to know how much water is there. What is our aquifer like? What are we sitting on right here? What's this thing look like? I want to characterize that with a cartoon in a little bit. And secondly, how much water do we take out of the aquifer? What's our extraction rate? You know, we have thousands of wells. What do we know about those wells? And what are we going to do about future growth? Sometimes I'm asked, what do you think the carrying capacity of Whidbey Island is? And one answer I give is, have you been to Stanley Park? You've been to the Robson area, the densest part of North America? Yeah, we can do that. Been to Hong Kong? We could do that. We could build enough buildings here to put 200,000 or more people on this island, those people that Richard said are coming from the Gulf. Those are Americans too. We can't really stop that. But we can do something about that. But we have to understand how much water that we're taking out of the ground. And we don't know that yet. The next essential question that we need to understand is, what is the replenishment rate? Where does our fresh water come from? And what is our rainfall recharge rate? Yes, we need to know that, because that's the only source of water that we have. And then, fourthly, the biggest question here is, when will we extract more water than is recharged? When will we take more water out than rain comes in? You heard Dr. Gammon speak about the intensity or the changing rainfall patterns. It's right here on Whidbey. And that is the point at which we will become, our water will become a non-renewable resource. So we would take out more than comes in. We're dealing, just like petroleum, we're dealing with non-renewable resources. So we need to get ourselves together and figure out how to answer these 4 questions. And that's what I'd like to talk to you a little further about. Really, it's a matter of knowledge. And we know in this whole knowledge system that there's things that we know. We know about the number of wells that are here. We know about some of the extraction rates of the larger water systems. We know a lot of information. The county, over the years, has put together tremendous water planning documents. I have one right here from 2005. So we know quite a bit. But there's also things that we don't know. And the crucial question is, what do we need to know in order to manage this island and to manage this wonderful place sustainably? What do we need to know? Can I go back one? Well, okay. Well, what do you need to know? So, we do know from our geological history, I get clicky on my hand here, that we're born from glaciers. We're not done like the Grand Canyon. We're actually sitting on top of a big pile of gravel. And it came here when the glaciers melted, and you've seen, maybe many of you have seen glacial moraines in various parts of the world. That's what we have here. And so there's gravel and various gradients, from large rocks to tiny sand to silt to compressed mud. Right? This is all the gradients we're sitting on top of. And the deeper you go, the more condensed the sedimentary rocks are. So, we also know that from about at least back to 15 or 20,000 years ago up to about 5,000 years, now speaking of thousands of years, Rich was talking about our lifetime. We know that there were glaciers here of varying size and depth. And then, since about 5,000 years ago, there have not been any glaciers on Whidbey. So if there's not any glaciers then, what has there been there? Well, that's when we have, full of forests. If you look at the paleo-pollen system, and you look at the pollen that's in the strata here and around here from the trees, we know that there was pretty much the same as we have in our old growth here. We have fir, we have alders, we have cedar trees. All the pollen was here. These trees encroached and created a forest as the glacier retreated. So, imagine where we're sitting to be under a glacier. You know, we might be up here someplace, right? Right where we're sitting. So, what happens is, this is the way that looked like from geological reconstruction. And you'll see that as the Cordilleran ice sheet was part of the big Canadian shield, and it came down to Fraser Valley, up here, and it scooched out through beneath the mountains up here on Vancouver Island and the Olympics. It scooched out here and plugged the Strait of Juan de Fuca with the Juan de Fuca road. And then between the Olympics and the Cascades, the ice kind of slithered on down here until global warming stopped it growing, right? Got almost to Centralia. And so as those glaciers and those two lobes receded, there's Whidbey. As the ice left. Now, to me, when I saw this, I thought, well, that's striking. Look at the strategic position that Whidbey's in. We've got the Strait of Juan de Fuca flowing in this way. We've got the top of Saley Sea down here, and we have then the islands of the Gulf Islands of Canada up there. What a strategic location we sit in globally. So, let's talk about that. Here's one of my favorite images of Whidbey Island. One of the things I like about it is you can see the vertical stripes down here that we go over the humps to go down to Clinton, and you can see the long valleys we drive up, and you can see all the way up some of the narrow spots in the prairies up in here, and then you can see our Cap Rock at the top. But what I want to talk to you about is, that's where our rainfall falls. That's our watershed. The whole thing. The rain that falls in the saltwater on the sea, we don't have much, it doesn't get into the aquifers. So the only water that gets into the aquifers is the water that falls on these two islands. So, if rainfall is all we get, and we're sitting here, then we have what's called a confined aquifer, I have a confined system right here, and you'll notice that it's confined because it has sides and a bottom. And the only way in or out is through the top. As a matter of fact, that's pretty nice water. Now, the question we want to address here is, our aquifer has a glass of water. Consider that just as an image. Are we here? Is our water full? Is our glass full? I wonder if we're here. And I hope the heck we're not here. So we don't really know, because we don't know our extraction or our recharge rate, the amount of water coming in, the amount of water going out. We don't really know where we're sitting with aquifer. We'd like to, and you can. I'll show you how. So if you'll permit me to take one step further, I'm going to cut a section right across where we're sitting between Langley and Clinton and Freeland, and look at this on its edge and develop a cartoon so that you might get this concept through. So if we start at sea level, right, that's, I can talk about mean high tide or anything, but sea level, what we have on the west side of the island is we have Admiralty Inlet, right? That's a channel of water, several hundred feet deep, of seawater. And on the east side of the island, we've got Possession Sound and Saratoga Passage, and basically we're surrounded by salt water. Now, we live on the top of this gravel mound in the middle. Right? That's Whidbey Island. That's where we are right now. We're standing on top of a big pile of gravel. Now, the glaciers, how deep does it go down here to bedrock? The glaciers presumably scraped at bedrock level. So how deep is the gravel beds that we're sitting on? We don't know. We've got some great geologists, and there's some great geologists here in our audience who might think more of details, but I'm not into numbers. I'm talking concept with a cartoon here. So we have then, it's reasonable to believe, this is all pervious aquifer, water holding gravels and what have you. Then it's reasonable to me to assume that the saltwater connection between possession and admiralty is real. There really is saltwater down there. We're not on bedrock, this is gravel. Now, I know that in my experience of 20 years with the petroleum industry, dealing with everything that came out of the ground in those facilities, I know that saltwater goes way, way down, 15 to 20,000 feet on a well. You can still get plenty of salt water coming out. As a matter of fact, they call it water cut in the oil industry. Every oil well that's ever been drilled, of the 1.5 million of them or something like that, from 2 to 6 barrels of water for every 1 barrel of petroleum is called the water cut. And so there's water way down there, but it's not drinkable. What we have here in Whidbey is that we sit on top of this gravel, and because of this salt water, fresh water floats. So here's our aquifer. Now, what happens is, we go along, we're trying to find where your well is going to start being salty. We want to find that out. Well, we can, but we don't yet because we're not knowing where the bottom is, and we have actually drilled thousands of wells from the top, surface, down. Most of the wells, actually, surprisingly enough, are right around above or below sea level. How much more water, fresh water, is there down there? I don't know. What we do know is that when fresh water and salt water meet, there is a gradient zone of salt, and I've got it here as a dashed line. There's a gradient. If any of your wells have been salted up, you know that the increased amount of saltiness grows over the years, right? It's not a sudden membrane, right? The membrane's thick. We don't know how thick it is, so we don't really know how much water we've got. Now, consider these wells, right? If you have a well that's over here near the shore, then the dip and strike of this membrane, you might be more likely to get salt earlier. With the sea level rise of 6 to 8 feet, right? If this sea level rises 6 to 8 feet, what do you think is going to happen to the volume of our aquifer? I don't know, but I'm scared about it, right? We need to think about it. We need to get out there 7 generations and figure out what we're going to do about it. So, let me just take a cross-section across the island here, right where this is driven. And this is the county database, a photograph of the county database of the number of wells that are in. There's Clinton down here, there's Langley up here, and here we are Freeland over here. We're someplace right in here drawn from one of those wells. I'm sure that our Director of Public Works in Langley can tell us which well that is we're on. Randy Perry's here, I saw her, thank you, Randy. But that's what the surface looks like. We have all this data. We know this. Every well that was drilled there was a drilling report filed with all the substrate they went through down to that level and where they hit water and how much water they had and how deep the well is, blah, blah, blah. So we have a great, huge database thanks to Doug Kelly and now Chris Kelly, our county hydrologist. So we need to get that and mine that for more. So now I'm going to take another tack on you, draw another bit of a cartoon. If we looked at a timeline over years, I'm going to talk about thousands of years here, and we assume that rain fell here. I think it's reasonable to assume that there was rainfall here on Whidbey Island 5,000 years ago through the old growth forest. There were people here, but there was also rainfall, right? I think we can assume that. Don't worry about the amount. That's not the lesson here. What we want to know is what percentage of that water gets into our aquifer. Now, in my studies and research I've done with papers, the recharge rate runs somewhere, maybe it's estimated between 15 and 20% of the rain. Somewhere in that range. We don't know for sure, but we can predict it. And there are methods, scientific methods that have already been done in other places where they can get a much finer bead on recharge rate. But for 5,000 years or so, right, the glaciers are gone, and I can think that we could assume it's pretty typical stabilized recharge rate. Well, then, European man, most of us, came aboard Whidbey Island with Mr. Eby here in 1850, and over the time since then, we have actually started extracting more water. I think that's reasonable to assume, don't you? People still thirsty. I don't know anybody that stopped drinking, water that is. And so here we are in 2023. We don't know what this is. I'm just giving this as a point. And the reason I have 64 in here, that was the first major USGS study that actually enumerated the wells and predicted our extraction rate. And then in 2005, the Ivy County Resource Management Plan has a very nice report called by the Water Resources Advisory Commission, which hasn't been functioning since before COVID, by the way. So if this is going on with our extraction rate, if we can determine the slope of our extraction rate, we could also then combine that with photogrammetry studies, which would talk about the relative resource absorption rate in our various ways we use the land surface. One of the reasons we're having this workshop today is there are many workshops on how do you deal with your surface, the surface you're in charge of. How do we make it more resilient, more absorbent, more friendly to the groundwater? You see what could happen? You see what's going on here? Out there someplace, those curves may cross. I don't know where that is, but I know it's out there. And I know that I'm going to call it, just for now, I'll name it, the critical sustainable zone. We will enter a time, maybe we've already entered it, I don't know. We will enter a time in which our curves of extraction and recharge may come together, in which case we killed our sustainable resource and we go into a non-renewable resource. That's when those two lines cross. We need to know that, don't you think? It's pretty important stuff that we know, especially if we're talking 7 generations in the future. Now, my lifetime, I'm all right. I got plenty of water. I don't even need an electric car. I'll still be fine in my lifetime. What about my grandchildren's grandchildren? It's my responsibility to leave something for them that's sustainable. So, what about the future? What about future rainfall? Well, Richard just talked to us quite a bit about that. What did I do? That's black screen. We know that the sea level rise. Mm-hmm. We know that extreme storms are likely. We're seeing that all around the world now. And when you get an extreme 10 inches of rain in a day, not very much of that gets to the aquifer. It runs into the sand, right? So we don't get much of that flash rainfall into the aquifer. And then our extraction rate, more people, what is the carrying capacity of our island? Interesting question. And we're going to get more runoff because we're going to, the more roofs that we have and the pavement that we have and our parking lots and what have you. If we just keep doing like we've always done, more water is going to run into the sand. So, if our ancestors could live and sustain this island for 200 generations or more, I think we can figure out how to get 7 more out of it and still be sustainable? That's what I hope we can do, and I'd like to show you how I think we can do it. Here is our question. Now, what we know is we need to do something. That's why we're here today, and that's why we need to get active and get really involved in our community, get into the community decision makings, do your own stuff at your house, do everything we can. We also know that, as Richard pointed out, a lot of people want to move here. And I don't know, every road I drive down here on the island, I see new houses being built, cutting out of the woods right off the highways. It's happening right before our very eyes. Why is it happening? Because the value of the property is still affordable. Because we value property in that way, that people will move as they can afford it. So that's not a good way to stop them on property value. But anyway, we can do that. Now the third one is, we know that climate change is real and pretty unpredictable. Uh-oh. What do we not know? We don't know how, and then John Lovey will give us a bit of a story of PFAS today. We don't know how the water flows in all these gravel beds and aquatards and what have you. The water is still flowing. Water does that. Okay, and it's just gravel and sand. It's not bedrock. Right? It looks just like the Stillaguamish River Valley. Drive up there and you'll see just what this looks like under here. Now, we don't know how much of that rainfall gets to our aquifer. We don't know that. We can estimate it. Are we 15%? Is it 6 inches out of 36 inches of rain that gets into our aquifer? Some of these predictions have talked about that. And we, surprisingly enough, we don't really know how much we're taking out. I know I'm a commissioner of Bayview Beach with Useless Bay Colony. I know that we take out an average of 3 million gallons a month. And the city of Langley is about 2 or 3 times that out of the wells there. So how much are we extracting? And the billions of gallons? Are we extracting 1 billion gallons a month out of our aquifer? It'd be nice to know, wouldn't it? Just how much we're taking out. Now, what we need to know, what we really need to know is, where is that critical sustainable zone? At what point will our area, will these extraction and recharge rate curves meet? That's what I think we really need to focus our attention on in the future. How do we get there? We get there by today's workshops and get involved. Run for office someplace. Your homeowners association, your county, your city, whatever you can, get involved. I know many of you are already. We need to put together, in my view, a coalition of knowledgeable stakeholders, many of which are here. And what they need to do, first order of business, is figure out what we know. Get the data together, and I would expect the county hydrology to be fully supporting of this, that we get together, sit down, and figure out what do we know about the wells, the depths, and what have you. The next thing to do is to figure out a scientific methodology to predict, and it may be there already, to predict that critical sustainable zone. We need to be able to predict that and not discover we've crossed it. Right? We got to be able to predict that. Now, then, it may be in the future, hopefully it is, we need to repeat this methodology, standard measurement stuff, repeat the methodology every year or so to determine our rate of approach to the critical sustainable zone. And that actually, I'm really proud to share with you that we now have, and this is part of the launching process, of Whidbey Climate Action. And WhidbeyClimate.org is now this coalition that is beginning to arise, thanks to all of you. There's a table out front in the foyer that you can sign up and find out more about it. The website's alive, and that's where we got to go. And then lastly, I want to appreciate you for coming today on this lovely mist day. I wouldn't call that rainfall. But remember, the questions that you have, and I hope you do, write them down. And at the end of the day, we'll have a full panel up here, and we can open up to all the questions at that time. If you want to communicate with me, I'm Perry.Lovelace@gmail.com. Thank you very much.